On this lesson, I will go over the OR probability. And as you might have guessed, probability. OR probability means you want to find the probability of something or something happening. So, for example, let's say we have a bag full of marbles. All right. So we have a couple of red, blue, green, and purple marbles inside our bag. And usually when you see OR, you can associate with plus. Okay, you're adding the probabilities. Okay, so let's look at this one. What is the probability of picking a red or a blue marble? And that translates to, whoa. I don't know what happened there. That translates to the probability of getting a red plus the probability of getting a blue. Now, this is true if the probability of picking a red and probability of picking a blue is mutually exclusive. Mutually exclusive, meaning if I do, is it possible to do both of them or not? So if I'm picking a marble, is it possible for that marble to be both red and blue? And the answer is, of course, no. The marble is either red or blue. There are no marbles that are both red and blue in this bag. Okay, so that means picking a red marble and picking a blue marble is mutually exclusive. Okay, so for mutually exclusive events, you can just simply add the two probabilities together. The probability of picking a red is going to be 3 out of, how many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the probability of picking a blue would be 2 out of 11. So the probability of picking a red or a blue is going to be 5 out of 11. Okay, so this is all under the mutually exclusive events. Okay, this is assuming that everything is mutually exclusive. Let's try another example, another mutually exclusive event. Let's say that you are picking a number from 1 through 10, and there's a deck of cards with a number on it. There are 10 cards. And you are picking a number at random. What is the probability of picking a 2 or a 6? Okay. Now, is it possible for you to pick both a 2 and a 6 at the same time? When you're drawing only one card, that card can either be a 2 or a 6. It can't be both 2 and a 6. So this is another mutually exclusive example. Mutually exclusive, so you just simply add the two probabilities together. Probability of picking a 2 plus the probability of picking a 6. And obviously both of these are going to be 1 out of 10 if we have just one card per number. And that's going to be 1/5. Okay, now let's look at some of non-mutually exclusive examples. So let's look at the same deck of cards here. What is the probability of picking a 2 or picking an even number? Now, this is not mutually exclusive because is it possible for you to pick one card that is both even and 2? Yes, you can. You can pick a 2, because 2 is an even number. You can pick 2, and that's going to be both a 2 and an even number. So this is a non-mutually exclusive event. So in this case, you can't just simply add the two probabilities. You can't do this because I think it's easiest if I show you a Venn diagram. Say like this one is probability of picking a 2. And this one is the probability of picking an even number. When you want to find the probability of picking a 2 or probability of picking an even number, you just want the combination of these two circles, right? That's what we mean here. Probability of picking a 2 or probability of picking an even number. But when these are not mutually exclusive, meaning there's an overlap here, there's a possibility that both of them can happen. For non-mutual exclusive events, the circles do not overlap. So for probability of picking a 2 and probability of picking a 6, they're not going to overlap because they can't happen at the same time. But this one can. And the probability of picking a 2 is exactly inside here. So this probability here is accounted for when we're calculating the probability for finding the 2. For picking a 2, probability of picking a 2. We've calculated that. And then when we're calculating the probability of picking even numbers, we're calculating that. And notice that the overlapped section here, the red section here, has been accounted for 2 times. It's been accounted for when we consider the probability of picking a 2 and when we've found the probability of picking an even number. So we've done this 2 times here. So that's why instead of just adding the 2 probabilities, we need to subtract, because we've done this 2 times, we need to subtract one of those times. Subtract probability of picking a 2 and an even number. Okay, so this is the rule for non-mutually exclusive events. You need to subtract the probability of picking both of them because they've been accounted for 2 times. Okay, so what is the probability of picking a 2? Probability of picking a 2 is 1/10. Probability of picking an even number is 1/2 or 5/10. Let's see, 5/10. And then probability of picking a 2 and an even number. There's only one number that's both 2 and even, so that's going to be 1/10. So this probability now becomes 5/10, which reduces to 1/2. Okay, let's try another example. Let's say I'm at a pet store. Or you are at the pet store and you see 4 dogs. Those are dogs, yes. They look more like sheeps. But anyways, we'll need a 4th dog here. Alright, we have 4 dogs. We have 3 chicken. We have 2 cats. And let's have also 3 monkeys. I'll draw tails so that they all look like people. Okay, we have 3 monkeys, 2 cats, 3 chicken, and 4 dogs. What is the probability, if you just choose an animal at random, what is the probability of picking a dog or a cat? Okay, now first of all, when you see an or, think addition. And second thing is to think, is it mutually exclusive or not mutually exclusive? In other words, is it possible to pick when you're picking one animal, is it possible for that animal to be both a dog and a cat? And the answer is obviously no. So this is not mutually exclusive. So if you're drawing a Venn diagram, there's a probability of picking a dog, probability of picking a cat. They're not going to overlap because both of them can't happen. So you just need to add the two probabilities together. You don't need to subtract anything. Okay, and the probability of picking a dog is 4 out of, how many do we have total? 12, 4 out of 12. Probability of picking a cat is going to be 2 out of 12. So that's going to add up to 6/12 or 1/2. Okay, so that's the probability of picking a dog or a cat. But if you look at probability of picking a dog or a four-legged animal. Four-legged animal, okay? Now, is this mutually exclusive or no? Is it possible to pick both dogs and four-legged animals? And the answer is yes, you can, because dogs are four-legged. So now that's going to be the probability of picking a dog plus the probability of picking a four-legged animal. I'm just going to write legs. And you have to subtract because, again, if you draw a Venn diagram, this has an overlap. Okay, there's a possibility that both of them can happen. So now that's going to be minus the probability of being a dog and four legs. So that's going to be 4/12 plus 4 legs. There are 6, that's half, minus 4/12. Dog and 4 legs is 4/12. There are 4 dogs. Okay, so we get 1/2. As it turns out the probabilities are the same. Now to spice things up a bit, let's assign colors to these animals here. So we have a couple of red animals and a couple of blue animals. All right. So what is the probability of picking a blue animal or a four-legged animal? And is this mutually exclusive? Is it possible to pick both a blue and an animal with 4 legs? And it turns out, yes, there's a cat, there are a couple of dogs that are blue. So this is not mutually exclusive, meaning you have to find the probability. Right? So again, if you draw a Venn diagram, this is the blue animals, this is the four-legged animals, and there are going to be a couple of animals that are in both. And when you find the probability of the blue ones and when you find the probability of 4 legs ones, it's going to be counted for twice. So you have to subtract the probability of being blue and 4 legs. So now that's going to be probability of blue 1, 2, 3, 4, 5, 6, 7 blue animals, 7 out of 12, plus 4 legs, 6 out of 12, minus the blue and 4 legs. We have 1, 2, 3, 4. Okay, so you have to subtract those 4 animals because they've been counted twice. They've been counted here and they've been counted here. Okay, so we find that probability, and that is going to equal 9/12 or 3/4. So that is how you calculate mutually exclusive and non-mutually exclusive or probability.